Imagine hearing that your city just experienced a 100-year flood. Does that mean we are safe for the next 99 years? Not at all. In fact, a flood of the same magnitude could happen again next year or even next month. This confusion comes from the way hydrologists historically described flood probability. Terms like average recurrence interval and annual exceedance probability are often used interchangeably, but they do not mean the same thing, and misunderstanding them can lead to serious mistakes in engineering design and risk communication. In this video, I will explain what these terms actually mean, highlight the most common misconceptions, and finally show you how these concepts are applied in real-world flood design applications. Stay with me. Floods are inherently random phenomena. Unlike engineered systems, river flows and rainfall are influenced by a complex interaction of climate, geology, catchment conditions, and human activities. Because of this variability, we cannot predict exactly when the next major flood will occur. Instead, hydrologists rely on probability theory to describe the likelihood of floods of different magnitudes. For example, the maximum flood peak of a river is treated as a random variable. Using historical data and statistical distributions, we estimate the probability that this variable exceeds a certain value. This concept is called exceedance probability, and it forms the foundation of modern flood frequency analysis. Today, the most widely used measure for flood frequency is the Annual Exceedance Probability, or AEP. AEP simply represents the probability that a given flood magnitude may be equaled or exceeded in any single year. For example, a 1% flood means there is a 1% chance in each year that this flood magnitude may occur or be exceeded. Importantly, this probability does not depend on past events. Hydrologic events are generally treated as statistically independent, meaning the rivers has no memory of last year's flood. This is why a 1% AEP flood could theoretically occur in consecutive years. For this reason, modern guidelines, including the 2019 edition of Australian Rainfall and Runoff, encourage the use of AEP rather than return period terminology because probabilities communicate risk more clearly. Historically, hydrologists describe flood frequency using return period, often called the average recurrence interval, or ARI. The return period is defined as the average time between exceedance of a given flood magnitude. However, the phrase 100-year flood has created widespread misunderstanding. Many people interpret it as one flood every 100 years, which is not correct. Because of this confusion, many modern guidelines now prefer probability-based language. For frequent rainfall and flood events, another metric becomes useful: exceedance per year, or EY. EY represents the average number of times a specific threshold may be exceeded within a year. This is particularly relevant for frequent storms or minor drainage events, which may occur multiple times annually. The relationships between EY, AEP, and ARI are provided here. Several misconceptions arise when these terms are misunderstood. The first is the waiting time fallacy. Some may think a 100-year flood occurs every 100 years, but in reality, it simply has a 1% probability each year. The second misconception is the gambler's fallacy. Some people believe that after a major flood, the system will be saved for decades. But in reality, the probability the next year will be exactly the same. Another misunderstanding is confusing probability and determinism, assuming that a 100-year flood, for example, must occur within a 100-year period. In reality, the probability of at least one exceedance in 100 years is only about 63%. That means there is still over a 1/3 chance that no such flood occurs in that period. These misconceptions highlight why clear probabilistic language is essential in hydrology. Hydrologic frequency plays a critical role in infrastructure design. Different structures are designed to withstand floods of different probabilities depending on their design lifetime, acceptable risk, and consequences of failure. Noting that different countries may have different guidelines for design, the worldwide recognized recommendations are as follows. Minor urban drainage systems are typically designed for 20 to 50% AEP and occasionally for 10% AEP events. These systems manage frequent nuisance flooding. Major drainage systems, however, often use the 1% AEP event, which is commonly adopted for urban flood protection and floodplain mapping. Bridges with major roads may also be designed for 1 to 2% AEP floods, while levees protecting urban areas may use even rarer events. For critical infrastructure such as large dams, engineers often consider the probable maximum flood, representing the most extreme physically possible event. Floods are inherently uncertain, so hydrologists rely on probability-based metrics to describe their likelihood. Modern practice increasingly prefer the annual exceedance probability because it communicates risk more clearly than traditional written period terminology. Understanding these concepts is essential for sound engineering design, effective flood risk management, and clear communication with decision makers and the public. If you found this video helpful, please share it with your colleagues and don't forget to subscribe for more videos like this. Thank you for watching, and I will see you in the next one.